Welcome back to our series Concepts in Arithmetic. In this video, we are going to be discussing some common divisibility tests. And these give us a quick way to look at a number, focus on a key feature, and determine if it's divisible by, for example, 2, 3, 4, 5, 6, 8, 9, 10, and 11. Okay, so we'll focus on all those, and that gives us a good way to check whether a number is prime or not. We can kind of go down a list of primes and see if our number is divisible by anything on that list, and get some more information about the number. Okay, so in this video we are going to focus on divisibility tests for 2, 4, and 8. Now, all the divisibility tests that we're going to work on focus on something called the divisibility lemma. They hinge on this idea. And the divisibility lemma says that if we have some number a, whatever it is, that is divisible by k, then the sum a plus b is divisible by k exactly when b is divisible by k. Let me change that little setting on my camera there. Okay. So let's do a picture proof. Okay, so the number a is divisible by k. That means, one of the things it means, is we could represent the number a, whatever it is, as a rectangular array with k rows. Okay, so this is my number a. There are a total boxes in here. I can't draw it out because a is an unknown. But there are k rows and a total boxes. Okay, so it says the sum a plus b is divisible by k exactly when b is divisible by k. So this is the scheme for the number a being divisible by k. Well, if I have a big total here, something like this, and the big total here is a plus b, okay, that's the entirety. The sum is divisible by k. Well, we already have in our premise that this part is divisible by k. This part is the a part. This part is the b part. Whoops, I'm off the screen there. Okay, so the entirety of my big rectangle has a plus b total boxes. If this side of the figure can be broken up evenly into k rows, then this part of the figure can. And similarly, if I start with this and I put on something that has k rows, then the resulting picture will have k rows. All right? So if each of the components is divisible by k, then the sum is divisible by k. And it also works the other way. If the sum is divisible by k and one of the components is divisible by k, then the other component also has to be divisible by k. And we're going to make use of that in our divisibility tests. Scooch out of the way here. Okay, this is one that most people apply without even thinking about it. The divisibility test for 2. And it says a number is divisible by 2 exactly when the last digit is divisible by 2. Okay, now the proof works the exact same way if I use any number of digits. So I'll just kind of show you an example of a proof with a 4-digit number. So the 4-digit number can be anything, A, B, C, D. Those are my digits. So we're going to take the 4-digit number A, B, C, D and write it like this, A, B, C, whatever that is, times 10 plus D. Okay, now this part is divisible by 2 because 10 is divisible by 2. So we're going to fall back on the division lemma. I have something divisible by 2, and I'm putting it in a sum. The division lemma says the sum will be divisible by 2 exactly when this second part, this last component, is divisible by 2. Okay, so if we do a concrete example here, if I were to do 5,678, and we were talking about breaking it up, this is 5,600, or 567 times 10 plus 8. Divisible by 2 because of the 10, divisible by 2, the sum is divisible by 2. Okay. Similar, but a little bit different, is the divisibility test for 4. A number is divisible by 4 exactly when the last 2 digits are divisible by 4. Okay, so we'll start like this. Take a 4-digit number. It works no matter how many digits we have, so let's just focus on something concrete here. So given A, B, C, D, we're going to write like this. Take the first 2 digits times 100. That kind of creates little spaces at the end, quote-unquote spaces. There'll be zeros, and then add the 2-digit number created by these guys. Okay, we know this first part is divisible by 4 because 100 is divisible by 4. So I'm taking a number that I know is divisible by 4 and I'm adding on something else. So the sum, the resulting number, will be divisible by 4 exactly when this number is. And this is a 2-digit number right here. Let me just do a quick example here. Um, 5,326. So we would write like this, 53 times 100 plus 26. Okay, that sum, 5300, 5300, that's divisible by 4. This is not. Okay, so this is not divisible by 4. If I were to look at, oh gosh, 1,764, okay, 1,764. 17 times 100 plus 64. The last one is divisible by 4, the last two, sorry. The last two are divisible by 4, so the sum is divisible by 4. Okay, and I do want to do a quick note as to why you can't just look at the last digit like you could with 2. Okay, so for example, 2,758, okay? If we look at that last digit, that is divisible by 4, but this number is not divisible by 4. If you don't believe me, we can go ahead and do the long division, okay? But 2,758, oh gosh, 4 goes into 27 6 times, that's 24, 35, that's an 8, 32. This could go in 9 times, and we see there's a remainder of 2, okay? So it is not enough to just look at the last digit when you're talking about divisibility test by 4. And the reason is because if we take this 275 times 10 plus 8, yes, this is divisible by 4, but this is not. Okay, and that's because 10, sometimes a multiple of 10 is divisible by 4, sometimes it isn't. When we were looking at the divisibility test for 2, you got a multiple of 10, it's guaranteed to be divisible by 2. So then we could just focus on this other part. But here, it's a crapshoot. This sometimes will, sometimes won't. So what you got to do is you got to consider a multiple of 100, which you know is divisible by 4. So we focus on this last part. That 58 there is not a multiple of 4. Okay. So the last test I want to do in this video is divisibility by 8. And a number is divisible by 8. And I'll be consistent with my wording from before. A number is divisible by 8 exactly when the last 3 digits form a number divisible by 8. Okay, so you can follow the pattern. You're talking about divisibility by 2, look at the last digit. You're talking about divisibility by 4, look at the last 2 digits. Divisibility by 8, you got to focus on the number formed by the last 3 digits. So if I were to do a couple quick examples, oh gosh, give me a number here. 5,200, or sorry, 52,000. Oh, 52,032. I look at the last 3 digits, 032, so the number formed there is 32. 32, of course, is 4 times 8. That's divisible by 2, so check. It works. 7,648. Look at those last 3. 648 is divisible by 8. 648 equals 8 times 81 if you do the division. Okay, so I'm looking at the last 3 there. So divisible by 8, divisible by 8. Let me do an example where the test shows it's not divisible. Let's do 7,000, and let's do something that's kind of close. 408. Okay, we're looking at that last bit. Ooh, that was divisible by 8. 7,428. Okay, 428 is not divisible by 8, as you can check. So this number is not divisible by 8.